Welcome back. Today we're going to be doing another optimization problem, so let's dive in. A rectangular poster must contain 800 square centimeters of printed material with 4 centimeter margins on the sides and 5 centimeter margins on the top and bottom. What poster dimensions will minimize the paper use? Okay, so first thing I'm going to do is I'm going to draw this rectangular poster. So in this case, what I'm going to draw here is we need 4 centimeter margins left and right. So we have like 4 centimeters here, and then another 4 centimeters here on this side. And then on the top and bottom, we have margins of 5. Like that. Okay, so therefore our total width is going to be the actual width plus an extra 8. Because if we have this is our width, right? Then the total width would be the same as the width we had before, plus the extra 8, plus the extra 4 on either side. And then a similar argument could be made for the lengths, right? We could say that this is our length, and then over here, we have that same length plus 10, right? Plus the extra 5s on either side. And so what are our constraints? We know that the length times width must be equal to 800. And so therefore, the length is equal to 800 over the width. And now what we need to do is we need to minimize the total area of the poster. Now, what is the total area of the poster? That would be the full width times the full length, right? Which would be W plus 8 times L plus 10, right? Full length times full width. So full area is equal to L plus 10 times W plus 8. And then I'm going to be subbing in the L is equal to 800 over W for L here. Like that. And then we're going to go ahead and simplify. All right, so multiplying the first one, 800 over W times W is going to be 800. Then we're going to have 800 times 8 over W, which is 6400 over W. Then we're going to have plus 10W, then plus 80. So therefore, we're going to end up with 10W plus 6400 W to the power negative 1 plus 880. So there we go. My next step is the actual optimization step. I'm going to find the derivative of our area, and then I'm going to set it to 0, right? Because that's what we in general do to optimize. We take the derivative of whatever it is we're trying to optimize, we set that derivative to 0, and we solve for whatever value we want to solve. In this case, we're solving for the width right now, and then we'll circle back to the length later. Okay, so therefore, the derivative, just using the power rule, would be 10 minus 6400 over W squared. If I set that derivative to 0, I get that 6400 over W squared is equal to 10, which means that W squared is equal to 6400 over 10. So therefore, W squared is equal to 640. And the square root of 640 is going to be 8 root 10, because recall that 640 is the same as 64 times 10, and root of 64 is 8, so it's going to be 8 root 10. And there we go. Next, let's find the corresponding height. So the height, or length, let's say. Well, the thing is, we said that the width was 8 root 10, and so therefore we know the length must be, as for this equation here, right, length must be equal to 800 over 8 root 10. And that is going to be 100 over root 10. And that is going to just be 10 root 10. And so therefore, in terms of what poster dimensions we have here, the poster dimensions are 10 root 10 centimeters by 8 root 10 centimeters. And that would be the final answer. As always, if you do have any questions, feel free to leave those in the comment section, and we'll see you for the next one.